Hello colleagues, my name is Alexander Zelenin and I'm software engineer with more than 15 years of experience. Today we are solving the remove key digits problem on leetcode with JavaScript. You can find the link to the problem in the description. This video is interactive. I will mention when to set on pause and what you need to do. The current step you are able to see on the right top panel. So, we will start with understanding the problem itself. We will need to take a look at the problem and try to understand it. We need to clarify what is coming in and should be coming out. In what format? Is it string, object, number, or something else? Try to think different cases. What kind of combination incoming variables is possible? Think about small, significant, repeated, and unique values. What if values are not provided? What if values has the wrong type or format or something like that? So let's go through problem itself. Given a non-negative integer num represented as a string, remove k digits from the number so the number is the smallest possible. Note, the length of num is less than 10,002 and will be greater or equal to k. The given num does not contain any leading zeros. And we have three examples here. So we have examples with k equal 3 and some number 1432219. And we have an outcome that expected from this example. An explanation. So we have three examples like this. So now set on pause and explain the problem verbally with your own words. Nice. We're receiving two arguments, a string that represent a number and integer that represent count of symbols we can remove from the string. The string consists of digits only and it does not have leading zeros. However, it might be just a zero. The string does not have any other symbols that are not a digit. The string can be up to 10,002 symbols length, so it's not fit in the integer range by itself. The count of symbols to be removed can be up to the same length as the string. We need to find out what digits to remove from the number to achieve lesser possible number at the end. So, okay. We understand the problem itself. What to do next? Design an algorithm. So, we can start with the most straightforward approach, call it do it yourself. Pick random arguments or take your own ones and try to solve the problem on paper like a human. Like just someone asks you, hey Alex, I have a number 10,200. What if, what one digit I can remove to get the lowest possible one? So pick up notebook and a pen, write down this number and solve the problem. Pick the next number, try to repeat, pick one more, repeat. There is some rules you can highlight. So now set on pause and try to solve it for 3 examples from the description, plus 1 additional from your mind. Just some random one. Great. So let me do the same. Let's start with some small examples and then enchant them. We'll take small numbers and we will remove just 1 digit. Then we'll try to remove 2 digits of them, and we'll find out what the changes. So let's start with number 10. So we will removing just 1 number right now. So maybe let me just to write down more. So 10, 10,200. Like this. Let me just to think some other examples. Let it be a lot of ones. Let it be 1, 2, 3, 4, 5. Let it be 5, 4, 3, 2, 1. Let it be. Let's start 100, 101, and enough for now. So we will removing just 1 number in each case. So with the 10, it's obvious that we can just remove 1 and we got 0. Like we cannot go below 0 since we have positive numbers. With 100, we have the same. We remove 1 and we remove leading 0. So we end up with just a 0. Everything is fine. With 101, we have 2 options. So we can remove 1 or we can remove another one. If we remove the first one, we end up with just a 1. If we remove the second one, then we end up with 10. 10 is obviously greater than 1, so we need to remove the first digit and 0. So what happens with 100, 200? In this case, we have again 2 numbers. We have 1 and 2. If we remove 1, we end up with 200. If we remove 2, we end up with 10,000. 10,000 is obviously greater than 200. So in this case, we again remove just 1. Let's take a look at next example. It looks harder than previous ones. So we have a lot of options here, like a lot of digits. Let's see what we will have if we remove first one. We'll end up with 400 something. If we remove 4, we'll end up with 132,000. Okay, this already looks smaller than previous one, right? If we remove 3, we'll end up with 142,000, which is higher than previous one. So the 4 is best case for now. If we remove 2, we'll end up with 142,000. For next numbers, it's also doesn't have any other changes. So in this case, the best option is to remove 4. We find this number by comparing all possible options. So what will happen with 1111? Like which one to remove? It doesn't matter which number to remove. So we can remove the first one, the last one, doesn't matter. Let's remove the last one, for example. Okay, So, because we end up with the same result. What if we have 1, 2, 3, 4, 5? If we remove 1, we end up with 2345. Okay. What if we remove 2? We end up with 1345, which is less than 2000. Okay. What if we remove 3? So let me maybe write down an options here. So we have 2, 3, 4, 5, 1, 3, 4, 5, 1, 2, 4, 5, 1, 2, 3, 4. Right? Did I miss something? 2, 3, 4, 5. So we remove 2, we remove 3, we remove 4, and we remove 5. Like this. So we have 5 options. We can compare them, and it's obvious that the last one is the lower one. So in this case, we want to remove the last digit, since it's a result to the lowest value. Let's take a look at the next example. Here we will have 4, 3, 2, 1, then 5, 3, 2, 1, 5, 4, 2, 1, 5, 4, 3, 2. Okay, I missed some of them, right? We remove 5, we remove 4, we remove 3, we remove 2, and we remove 1. Yes, so like this. So in this case, we have totally opposite one. So the first one is the smallest. So we want to remove 5. So the first possible approach that we had find out is to remove every number and compare results. With this approach, we have 2 steps. First step is generate all possibilities, like this one. And second step is to compare them with each other to find the smallest one. To identify the efficiency of our algorithm, we need to calculate complexity. Space complexity is how memory usage affects by incoming variables, and time complexity is how CPU usage affected. We need to find a formula. Is it linear, cubic, or maybe logarithmic one? Is it required to understand will our algorithm perform, how our algorithm will perform on big data sets? So to find space complexity, we need to find out what data structures we store. Now set on pause and try to guess. Awesome. The space complexity in this case will be n square. So we have n square. The n square by the reason we store every possible value for every digit. So we have the string of n digits, n digit string. We copy this string n times because we just remove every number. So generally it's n minus 1, n minus 1. So yeah. And n minus 1, it's count like as nn. So we end up with n square. So to find time complexity, we need to find out what operations we repeat every time on each step. So time for pause and think about this. Okay, for an algorithm with the one digit, time complexity will be also n square. So let me just change color to another one, n square. N times we copy our string, and copy the string itself could take up to n time, since it's required to copy every symbol. To mention, some modern compilers can do this more efficiently by saving a link to substring instead of copying each symbol. So it can be less, significantly less. Also, we need n square to compare them to find the best one, because comparing of strings took up to n time, and we do it n times. So like plus n square. So, but we end up with also n square. Okay. What if we need to remove more than one symbol? So if k more than 1. Then we have another parameter in our formula. How it will affect space consumption? It will not, since from previous step we took only one number. The previous structure is not going to next step. We just pick the number itself, and it doesn't affect algorithm further. So how it will affect time consumption? It multiplied by k, since we need to repeat this operation k time. So we will have k n square. Okay, we had designed our algorithm, at least the first approach. Let's optimize it. First of all, let's think about our constraints, like what is the best complexity in the worst case. We expect to return a new number, so at least we need to store this number. In the worst case, when we remove just one symbol, so the final number is just one symbol less the original one, so minimum space complexity will be on. So it will be on. It's minimum possible one, because I had explained previously. If we are required to remove the last number to achieve a minimum value, we are going through every symbol. So time complexity will be also on. So, but just for one symbol. So it will be on. So this complexity is the best scenario we had found out. Now let's think about how we can go from on square. Let me choose another color. Okay, it doesn't like this one. From n square to on. And in time consumption apps also from kn square to on. We can do it separately for the space and for time. By analyzing our cases, we can find out some patterns. One of them is every time we remove a leftmost value that has a smaller value than a right number after itself. So, I mean, for example, here we have 1, then we have 4. After 4 we have 3. So the number initially was increasing from 1 to 4, but then decreasing from 4 to 3. So when we find this step, when number is decreasing, we can be sure that this number, the greater one, should be removed. So let's take a look at our previous example. Is it valid or not? So we have 1 and then have 0. 1 is greater than 0. We remove 1. The second case is the same. The third case is the same. The fourth case is the same. This case we already take a look. If all numbers are equal, we can skip up to the last one and remove the last one, since we don't have other numbers. So we can count other numbers as 0 if there is no such. For 1, 2, 3, 4, 5, we see that every time our number is increasing at every step. So, and in this case, we remove the last number, since we go to that number and remove it. In the next case, we start with 5, the greatest digit in this sequence, and right after 5, we have 4, which is lower than 5. So we remove 5 and get the lowest result. We can repeat this algorithm further. So for example, when we end up with 1, 2, 3, 4, we also compare the last digits with what we have. So we will end up with 1, 2, 3. In this case, we will end up with the same number and we will remove 4. So we will end up with 3, 2, 1. So with this approach, we will go through our string maximum 2 times. So I mean for big K. So if we have like 1, 2, 3, 4, 5 and we need to remove 4 numbers, first we go to last number and then start to removing them one by one and end up with just a 1. Okay. So also we store just new result. So we doesn't store any other data structure, so memory consumption will be on, as we expected initially. So we achieve our best scenario and further optimization not required, at least for now. There is possible some optimizations, but they are not necessary, since we achieve like best algorithmic complexity. So it's time to write some code. Okay. So let me first fix the problem we have here. Not the problem, but just to make linter happier. let's make just it, name it function like this. Okay, so we have our new string. Generally, we can start with transforming our string to array. It will be easier to work later on. So we have num, and we will transform it to an array. We will split it one by one symbol. Let's call it numArray. It was not happy because I rewrite the incoming variable, and it's a bad practice to do like this. Okay, and we will need to construct the result. So result will be equal to new array. We will we need to return a string, so we will construct a string from our result. Result, let me just check for a second. Yep. So we join every symbol in result. So now we need to fill the array result with our values. So we will go through our array. Let's make a cycle from the first to the last one. So when I is less than num array length, increase it by 1. So and we can start with just putting our value. So result push. It's not our value. I want to also create a digit variable. So current digit. So digit will be equal to num ri. I especially try to write with the simplest syntax possible to make it better, easier to understand. We can work on that later on. So we got our digit, and now we will need to compare it with the lastest digit in our result. So result length minus 1. This will represent the last symbol, but only if result exists. So if okay, what we need to do with this the last digit in our result is to take a look that this number is greater than our new digit. If this number exists and it's greater than, so we can do it like this, length greater than 0, and this number, the last number in our result, is greater than our digit. Also, a very important thing, we have string and we need to transform the symbol to a number itself, so we need to add the parseInt function to transform it to number, since we want to compare numbers and not strings. So we will compare result and if previous value greater than new one, we will remove it from a result array. So we remove the last value and we reduce k by 1, since k it doesn't happy to modify it. Okay, let's create counter equal to k, and we will work with counter. So it's a good practice to not modify incoming variables to avoid side effects, but sometimes it requires exactly to modify them, but that should be explicitly. So we need to check that our k or counter is greater than 0, so we can add the condition here. So if counter is no, sorry, not here. We will do it here. So if our counter is greater than 0, only in this case we will able to remove some numbers from this, and we push our new digit every time. So after the cycle ends, it is possible that we will still have some case left. For example, if we had go through some case where we have 1, 1, 1, 1, and so on. So we never have the symbol that is greater. And also we will need to skip zeros. So 1 second. So we have counter. What if our digit is 0? If our digit is 0 and a result is empty, we should not put anything to our result. So if result length equal to 0 and digit is also 0, no, we should revert this logic. So if this condition are met, then we should not push our value. So if let me rewrite it. So generally we can just revert it like this, and it will be fine, but I want to make it a bit clearer. So if digit is greater than 0, or the length is not equal to 0. Yep, like this. So we remove only digits. We push our number only if it's greater than 0, or if we already have some numbers in our result. So then if if our counter is greater than 0, we will remove last numbers. So counter, we will remove 1 by 1, and just remove numbers from our result. So okay, what we have right now. Also, we need to add some additional conditions for situation when k is equal to number length. So